And unfortunately, let me talk a little about these points of view and compare them. Unfortunately, these points of view are not the same. Well, let's start with geometry. Well, you see, what does it mean to look at a function from 3 independent variables to 3 independent variables? How to visualize that? How did you visualize a function of one variable? You draw x-axis in one direction, y-axis in the other direction, and you think of those two as two different parameters. So in this case, you will need that many different parameters, that many x's, and plus that many x's, total 6 if you think of 3 plus 3. So you need 6-dimensional Euclidean space to visualize a function from 3 variables to 3 variables. So the problem about geometry is that dimension that we have, that we experience and can visualize, is limited by 3. And that means you can only consider functions from 1 to 1 variable, or 1 to 2, or 2 to 1. And that's it. You cannot even consider 2 variables to 2 variables so that you can visualize what it means. That's a limitation, a serious limitation of any geometric consideration. Physics. Physics has kind of the same limitation. Because we live in 3-dimensional space, we cannot experience forces in 4-dimensional space. Right? So dimension is also a limitation for physics. But more than that, the fundamental understanding of linearity comes with this idea of relating something, a process, to time. And we usually treat that time as independent variable. So basically we need to limit ourselves to one independent variable being time. This is the only case when we can physically understand what linearity means. So one independent variable having precise meaning of time. Right? So that's serious limitation on physics side. And there is absolutely no limitation for algebra. Algebraically, you can write down as many variables as you want, being independent, being dependent. You can write down any formula as long as it takes. Right? So algebra has no limitation. And also, it misses something else. What is it? Algebra has no meaning. I hate to tell you, it's completely meaningless. Unless you think of what you write in terms of geometry, or in terms of physics, or in terms of something else. So this advantage of having no limitation comes with that drawback of carrying nothing with it. So we will have to bring meanings from geometry and from physics to algebra so that all we do makes sense, but still we can do it effectively, quickly, using a computer. And then we will generalize, we will mimic the procedures we understand to the cases when we have more variables as independent or dependent.